So today I'm going to show you another way to complete your genetics problem called the forked line method. And the forked line method is good because A, you don't need to make the Punnett squares, and then B, you can use it to do problems that are bigger than just your regular dihybrid cross. So you could do it with a problem that has, say, 3, 4, 5, 6, 7, up to 1,000,000 traits. So you can do it with kind of any sort of genetics problem that you see. It's really simple to do. You only need to know how to do a regular 2x2 Punnett square, and it can save you time. So it's just a different way to solve these genetics problems, but it may or may not be easier to solve using this method. And when I give you a problem from now on, you can choose to either use the 4x4 Punnett square, or you can use the forked line method, whichever is easiest for you. So let's take a look at a problem something like this. Let's say we have two traits. We have tall and we have short. Tall is dominant, short is recessive. And then let's say we have a second trait, color, green, which is dominant, and yellow, which is recessive. So here are my two parents. My first parent is homozygous dominant for height and heterozygous for color, tall and green. And then my second parent is heterozygous for height and homozygous dominant for color. He's also tall and green. So I want to go ahead and figure out this cross, and the old way of doing it might have been to go ahead and make you first use FOIL, first, outer, inner, last, to figure out my gametes, and then use a 4x4 Punnett square. For this, what I'm going to do is I'm going to do something a little different. So what I'm going to do is I'm going to treat each one of these sets of letters like a monohybrid cross. So first I'm going to cross the T's, and then I'm going to go ahead and I'm going to cross the G's. So I'm just going to do each one like I normally would in a monohybrid cross. So I'm going to take the two capital T's from this parent. I'm going to go ahead and put those on top of a 2x2 Punnett square. And then I'm going to do this one, and I'm going to put him on the side. So big T, little t, and then I'm going to cross like normal. Big T, big T, big T, big T. Big T, little t, big T, little t. And then I'm going to go ahead and just write out my results from that. So I have 1/2 are big T, and 1/2 are big T, little t. And now I'm going to do the same thing for my G's. So I'm going to go ahead and make another Punnett square over here. I'm going to do big G, little g on top of a 2x2 Punnett square. And I'm going to go ahead and I'm going to put big G over here. And then I'm going to go ahead and fill out that Punnett square. So big G, big G, big G, little g, big G, big G, big G, little g. And then again, I'm going to just write out my results for this one. So I have 1/2 are big G, I have 1/2 are big G, little g. So this isn't anything different than you've already done before. The only thing is that I just split up the two traits and did them each in their individual Punnett square. Now to figure out, well, what offspring would I get from both these traits kind of combined from a regular dihybrid cross, I'm going to make what's called a forked line diagram. So what I'm going to do is I'm going to take the results from my first Punnett square over here, and I'm just going to write them down off to the side. And when you do this, it's important that you leave lots of room. So 1/2 big T, 1/2 big T, little t. Now what I'm going to do is I'm going to take the results from my second Punnett square, and I'm going to attach them to the results of the first. And since I have two results from my first square, I'm going to attach them both, making what we call a forked line. So watch how I do this with the first one off this big T, big T. I'm going to draw an arrow going to 1/2 big G, I'm going to draw a second arrow going to 1/2 big G, little g. And then I'm going to draw the same results coming off of my second Punnett square here. So 1/2 big G, 1/2 big G, little g. The rule is that I write the results from the second square off of each result from the first square, if that sort of makes sense. And now to actually figure out, well, what will my offspring be, all we do is we follow these forked line diagrams across and we multiply. So we have 1/2 times 1/2. Well, 1 times 1 is 1, 2 times 2 is 4. So 1/4 of them will be big T, big T, big G, big G. Big T, big T, big G, big G. And then I do the same across here. 1/2 times 1/2. So that'll again give me 1/2. 1 times 1 is 1. 2 times 2 is 4. And then that's going to be big T, big G, little g. Big T, big G, little g. Then I do the same down here. I'm going to do 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. So that's 1/4 big T, little t, big G, big G. The same thing with the last one. 1/2 times 1/2, again, is 1/4. 1/4 will be big T, little t, big G, little g. And now you can see these are my results here. If I were to do a regular 4x4 Punnett square, I get these answers right here. Those are the results from my dihybrid cross. So you can see this method is a little bit easier. It only requires you doing these 2x2 squares instead of 4x4 squares. It just requires a little bit of math and that you make this diagram right. Now let me go ahead and show you how you might do this with a more complicated problem. Let's say a trihybrid cross. So now I'm going to go ahead and show you how you do this with a trihybrid cross. So this is an example where we might be trying to track 3 traits at once. Maybe we have a trait for maybe, let's say, height. Maybe we have a trait for color. Maybe we have a gene for hairstyle. But anyways, we have 3 genes, so now we have 6 alleles. So I'm going to go ahead and ask you to figure out all the combination of T's, G's, and R's, and then try to make a very big, large Punnett square. Instead, what we're going to do is we're going to go ahead and use that forked line diagram. So we're going to go ahead and make a square for the T's, a square for the G's, and a square for the R's. We're going to do these all separately in their own 2x2 Punnett squares. I'm going to go ahead and do that really quick. So you can see here that I went ahead and took my capital T, my little t, I went ahead and made a Punnett square for that. Capital G, lowercase g, made a square for that. And then I took the capital R, lowercase r, and the lowercase r, and I made a square for that. So I've gone ahead and made my 3 separate Punnett squares. Now what I want to do is I want to go ahead and start my forked line diagram. So first I have to figure out, well, what are my results from my 3 separate squares? So looking at my first square, big T with little t, what did I get inside my square? Well, if I look, everyone inside my square is big T, little t. So I got 4 out of 4 are big T, little t. Now I'm going to go ahead and I'm going to look at my second square over here, and I can look and see my results are 2 out of 4 big G, and 2 out of 4 big G, little g. And it doesn't matter if I write 2 out of 4 or 1/2, I'll get the same answer either way. Let me go ahead and get the results for my last square here. I have 2 out of 4 are big R, little r, and 2 out of 4 are little r. So those are my results for my 3 squares. Now it's time to go ahead and make my forked line diagram. So I'm going to go ahead and start off by taking the results from my first square and just drawing them off to the left here, just copying them back down. So I have 4 out of 4 are big T, little t. Now I'm going to go ahead and I'm going to take the results from my second square and then attach them to all the results from my first square. I only have 1 result from my first square, so these 2 results just need to come off of that first result. So let me go ahead and do that. I'm going to fork that diagram. Do 2 out of 4, big G, 2 out of 4 are big G, little g, right? Now I've got to go ahead and I grab the results from my last box. The rule is I'm always going to attach the results from my last box to every result of the previous box. So if you look, I have 1, 2 results here. I'm going to have to draw these 2 results coming off of each of those. So watch how I do this. I'm going to go ahead and write 2 out of 4 are big R, little r, and 2 out of 4 are little r. and then I have to write them coming off of this one as well. 2 out of 4 are big R, little r, and 2 out of 4 are little r, little r. So I have to go ahead and write those results coming off of each of the previous results. And now the trick is just to multiply across. So all of these kind of ends to the diagram are going to become answers. And now I'm just going to multiply across. So 4 out of 4 times 2 out of 4 times 2 out of 4. Well, let's multiply the top here. 4 times 2 is 8. 8 times 2 is 16. So my first one is going to be 16 over 4 times 4 times 4. 4 on the bottom, 4 on the bottom, 4 on the bottom. So 4 times 4 times 4. If I did it right, it should be 64. So 16 over 64 are going to be, this is the tricky part, big T, little t, big G, big R, little r. Just got to follow that diagram across. So big T, big G, little g, big R, little r. Let's go ahead and follow the rest of my diagrams. So here we go. 4 out of 4, 2 out of 4, 2 out of 4. It's 4 times 2 times 2. It's going to be 16 again. 16 out of 64 are going to be big T, big G, little r, little r. Let me go ahead and do the next one. 4 out of 4 times 2 out of 4 times 2 out of 4. It's going to be 16 again. 16 over 64. And that is going to be big T, big G, big R, little r. And then I'm going to go ahead and do the last one. 4 out of 4 times 2 out of 4 times 2 out of 4. It's going to be 16 over 64. Our big T, big G, little r, little r. So you can see here I've just figured out my results from a trihybrid cross. You can see each child over there has a set of 3 letters, or 3 sets of letters, and I have 16 out of 64. I could go ahead and reduce these fractions. I get 1/4 are this, 1/4 are that, 1/4 are this, 1/4 are that. So a quarter are going to be these results here. So that's how you go ahead and use the forked line diagram to solve a little bit more complex genetics problems.